Yo, what's up, what's up, what's up, what's up? Welcome back, everybody. Today we are working on our video editor. So, the idea behind the project. I wanted to experiment with cutting down my long VODs into shorter chunks to see if, can I make, a 20-minute thing out of this that makes sense in any way, shape, or form. I took a run at it, and holy, it was not trivial. I tried to use, I don't know, KDN Live or whatever, and there's a video timeline. I'm scrubbing through it and trying to figure out okay, I'm trying to cut out dead space. I'm trying to find the parts that are interesting, and I'm pretty sure it would have taken me at least 4 hours to cut down a 2-hour video. The point of me doing this is that I'm supposed to be having fun, programming, doing whatever I feel like, and then posting that on the internet as a side effect. I don't want to put 4 hours into a 2-hour chunk of coding. That doesn't make any fucking sense. So, I'm thinking if we could generate a set of subtitles for a given video, then I could read through the script of what happened and say oh, this part's interesting, this part's not. Cool. Then if I was able to kind of select chunks of text and say I want that part in, I want that part out, maybe I want to label them so I can experiment. I think that would really, really speed things up, as well as if I had some sort of auto cut of dead audio segments, right? Maybe I see I'm thinking about something, and instead of me just going there thinking for 20 seconds, that just automatically gets stripped out by some intelligent process. So that's kind of what I'm thinking. And so the plan is we are going to make a video editor that uses OpenAI Whisper to generate subtitles. Then we will take a video and we'll display it to us, the user, me, through OpenGL and FFmpeg. So FFmpeg will parse the data and turn it into a picture that goes onto the GPU, and the GPU displays it on the screen. Great. Then I want to attach a script to the timeline so that I can kind of select areas, at least scrub through the timeline based off text, and then the last piece would be a tagging system that says okay, I want this segment, this segment, this segment. Re-encode these back to back. Try not to re-encode if you don't have to. Just copy paste what's in the input, and bing bang boom. Hopefully we're there. So where we are at today, zig build and run. We have a OpenGL window that opens up. It can open an MP4 file with a very specific encoding and color format. It can render this, and that's about it, right? So we have no sound. We have, there's a lot of things wrong with this, right? We have no playback control. So what I want to work at today is trying to get this a little closer to a usable video editor, or at least usable video player. So I want to first split out some code for the GUI stuff so that it's easier to work with. I want to fix this chunk of emptiness on the right, and I want to fix the aspect ratio as well. And then I want to add pause play, and then add a rudimentary progress bar. So this is not the final GUI. What we're doing right now is we just have GLFW, a OpenGL window, and that's it, an OpenGL canvas. Eventually we're going to have to upgrade to some sort of real GUI framework. But I think we can save that for another day, because I think the longer that we put off that decision, the better our API is going to look there, because very, very likely the GUI is not going to be written in Zig, which means that we're going to have some sort of complex C API boundary that involves running a GUI thread and the main app thread in Zig. And so understanding how those components interact will be easier the farther we get along the process before making the switch. So the plan for today is we can easily just show a little blue bar at the bottom in OpenGL without having to do any widget programming, and we can use GLFW to just parse where on the screen I clicked, and that will be good enough to implement some form of seeking. And if we happen to blast through all of that, then we'll start looking at audio, but I really doubt that we're going to get into audio today. That's probably a thing for tomorrow. Probably. All right, so that's the context we need, and let's jump in. So the reason I want to start splitting stuff out is because right now, adding anything just kind of gets shoved into our giant main function. So we're kind of just using OpenGL hella directly here. And so as we start adding more state, things are we paused, are we not paused, or as we start adding state, what's the window size, and we want to inject that into our shader so that it can correct for the aspect ratio, that type of thing. It's just going to be simpler if we split things out first. So I think we're going to need some sort of GUI And this is probably, I don't know what this is going to do yet. I guess he's going to have some sort of like state that is probably going to be like these YUV textures that he's loading up to the GPU that are like the YUV planes of the video. So FFmpeg is like he's taking like file and it's going into like FFmpeg, and what comes out is like chunks, like what I think they call them frames. So these frames might be video or audio, and if it's video or audio, if it's video, we have like Y, U, and V for like color data in like separate buffers. So these all get uploaded into the GPU. These are all happening on CPU right now, I think. I mean, FFmpeg does have GPU accelerated decoders, but I don't think we're using them right now. And so these textures are like, we extract these buffers, shove them onto the GPU, and then ask the GPU to show them to us through OpenGL. So that's what this stuff is. So we're gonna have like Y texture is whatever the fuck this thing is. A CGL uint. Which means that we need, I guess, in order to get OpenGL in here, then we're going to need to have C in here. And right now our C is kind of like stuck at like the root level of the project, which isn't really great because, how do I say this? We could just like pull out the OpenGL stuff, right, and like shove it in here. But the Zig docs recommend that you don't do that because every time you call this C import block, it like spins up the LLVM like parser and like whatever the fuck LLVM is doing under the hood. So they kind of say like, try to do it only once. So I guess we'll make like one import that's called c.zig, and we'll just kind of like shove all this in here. And I think there's like an inherit keyword. There's some keyword that lets us say like, hey, take all the stuff that comes out of this thing and like pretend that it's in my namespace. And I'll have to look that up. You inspire me, man. Hey, thanks, man. I appreciate it. That's good to hear. A good side effect of what we're doing here. Zig documentation. Using namespace, that's probably it. What a funny keyword. So we'll add this, and then, so here we should be able to say const c is equal to import c.zig. And if we did that part right, at the very least, nothing should be broken right now. So let's just do a quick little checkaroozles there. No, C has no member called GLW in it. So what's going on here? What is going on here? I could have sworn this is how you're supposed to do it. Using... Warning, using namespace will probably be removed from Zig in 0.13. Do you know if there's going to be like a replacement for it? Yeah, this is what they say to do. They do just say to just write using namespace and then C import. So I don't understand why this would not be doing what we want. The root of file C has no member named GLW in it. Possibly, but the dev team isn't sure yet. Yeah, I think I'll wait. We can address whatever the problem is as it comes. So I don't understand why this isn't working. This has worked in previous times I've tried this. Pub, thank you. Thank you. Good eye, good eye. Cool, okay. So now this is available to us from our GUI side, and then we can do the same imports here. And now our Y texture is available to us. Sick. Okay, so U texture, we're gonna have Y, U, and V. And is there any other state that's associated with this? Probably the OpenGL shader program that we're using, which is probably also just a GL uint. Yep. And is there anything else? The vertex and fragment shader get kind of, they can go away after we've compiled and linked them, so we don't have to really worry too much about that stuff being stored long term. Start time, this is external to like the GUI stuff. This is more like our main loop feeding the GUI. We'll be using this. And then we bind textures, upload data. Yeah, I don't think there's really much else that needs to be stored here. So, we're gonna have to initialize this guy. and he is going to have to return itself. So we have to say, hey, we have a reference to our type, which is this. And then we say init return self. And certainly he'll be able to fail in some way. And if he can fail, then that means that we should return some type of error. GUI error is equal to this. And we'll figure out what goes in there later. Okay, so pretty much all of this initialization stuff is going to go in here. So he's going to try to create a window. He's going to try to initialize the OpenGL context. He's going to create his program. And then he's going to create his textures. And I guess all of that kind of just goes right here. We need our error callback and GL debug callbacks belong in this function, or in this folder now. File, I should call it. This should be a public function. And clearly he's going to have some inputs, but we'll figure those out in a second. So I guess this is a raw struct, so we import it with a capital G for GUI. And which kind of means that probably the file itself should be uppercase. I think that's the convention in this language, where uppercase is for types, and your names, since they can be used as types directly, should reflect that. Okay. I guess that means also this doesn't have to be called GUI error. This can just be called error because it's within our GUI namespace, which is kind of cool. Kind of nice. All right. All right, so I guess we just kind of, what are we going to do here? To like incrementally make progress, we're going to comment all this out, and then we're going to say var GUI const GUI is equal to GUI init. We're going to try this, and then we're going to afterwards deinitialize this at some point, which means that we need some sort of deinitialization function here, which I'm going to put at the top here before helper functions. And he is not going to be able to return anything, so he's going to go like this. And his responsibility is to delete all of his textures. So these defer delete textures now have to kind of go down here. But they should actually still stay where they were if there's a chance of going out of scope. So I don't really know how this works, but in my head, it makes sense, even though there's no error cases right now, it makes sense to error defer free these guys now, just in case later we add something that can error out early later. This will make sure that, because later I'm not going to go back when I added return and check, oh, did every single thing that get allocated here get deallocated? So I think that makes sense. I think it makes sense. And then down here, we are going to delete this, delete this, and change all these error defers to defers. I'm kind of hoping that the Zig compiler is smart enough to see that there are no errors returned after this error defer and just like nukes it. That's what I would hope. And if it doesn't do that, it's like an optimization that could be done, I'm pretty sure. Okay, what else needs to be deinitialized here? We have Y, UV, and program. So surely somewhere where we, yeah, this is error defer now, and then we just slap this guy down here. Boom. And these guys actually don't have to be deferred anymore. These is just, we're doing this. You can't stop us. Okay. Now, this decoder is not part of the GUI. Make texture does not exist here, so that's probably in main. Make texture. This will also come and live in the GUI stuff. Down here. And expected type found void, so we need to return something here. So return something. Are you giving up Rust for Zig? I don't know. I'm enjoying writing Zig right now. I can't really place strongly why. It just feels nice. So I'm just gonna keep doing it while I'm enjoying it. I still like Rust. Rust is pretty cool. Yeah, I don't know. We shall see. Okay, so this guy has these things to return. Are the compiler errors good? No, the compiler errors are awful. No offense to anybody working on Zig. They're just not there yet. Like, Rust compiler errors are insanely good. They guess what you were trying to do, and they figure it out for you. They tell you, hey, you probably meant this. In Zig, you're kind of lucky if it tells you what the actual problem was. Well, I guess I shouldn't say that, because they always tell you what a problem was, but it's like just even getting like the context of like why, like, how do I say this? Like, if you pass in like the wrong type to a comp time function and it does the wrong thing somewhere down the hood, it's hard to understand like where did this type come from. That needs to be like shored up a little bit. I know that it's got a lot better in O12, but it's still not. It reminds me of C++. No, I was gonna say it reminds me of C++ template errors, but nothing is as bad as those. Holy, those are bad. That's your issue with Zig. Yeah, I mean, it's definitely like, you could definitely tell it's not done, right? Like, documentation isn't there. I'm fine with that. It's not like I can read anyways, so it's not a big deal for me. And like, yeah, and yeah, there's some like rough corners, but I'm lucky enough that I've got enough programming experience under my belt that I don't really find them to be too bad. It's never like, I'm never like, what is happening? It's like, oh, okay, we just have to like dig a little bit to find that out. Expected type found void. What the fuck is this talking about? Oh, because I didn't write error here. Okay. Expected type error here, so we can say we have initialization errors. Is there anything else in here? No, that's actually the only error type, which is kind of nice. So does this build? Do you have any comp time code right now? I don't think I've got any in this project. I did some in another one. I think what have we even written in Zig recently? QR decoder. Not in this one. I'm pretty sure I have some somewhere, because I've definitely written something. Maybe in our QR decoder. Yeah, we have like nothing like too crazy. We do have like, you know, if you take in a writer, so you want to like, you have like some generic type and you don't know which one it's going to be, so you want to implement for all of them. That type of stuff is pretty, yeah. No, there's not, I haven't done anything like super advanced in here, I don't think. I can't think of anything. Can't think of anything. stdlib uses comp time a lot for stuff. Yeah, for sure. It's definitely like, it feels more useful as like a library thing. Kind of, so far. We'll that's very hand wavy, of course. There's obviously cases where that's not true, but like, it's kind of like templating in C++, right? Like, you can get away without using them a lot. And in fact, I've kind of recently started deciding that like, I think generally staying away from trying to handle genericism, is that a word? Like, just makes your life easier. I'm like way more okay with a little bit of duplication than I am with like the complexity that comes from trying to manage working with infinite types. Of course, grain of salt there. There are times where it makes sense, but I trend more towards not writing comp time type stuff now than I would have before. Dude, does this build? No. Defer GUI dinit because he takes himself in by mutable reference. Maybe that's not necessary, but whatever. We'll just write var here. Okay, we build, and so now, what does our main loop look like? All of this stuff goes away. Beep boop, beep boop. Except for this decoder, we still need our decoder. And these textures go away. We still log our start time and get an image. And this main loop is probably going to go in here somewhere. So we're going to say like pub. We're going to have some function here, render, right? Every frame that our GUI runs, we're going to render something. And maybe this can error out. It doesn't look like it can, although maybe that just means that we're not checking OpenGL errors, which we should be doing. We should also be checking here, should close. What do you like about Zig? Sorry for the guys to talk, just curious. Oh, no worries. I can just choose to not answer you if I don't want to talk about it. It just feels simple. Like, it feels simple and safe, right? Like, something that I've written a lot of Rust, and I like Rust a lot. But it's, you have to work to fit the abstraction sometimes. And usually that's worth it, right? In Rust, there's something where, like, when I write Rust code, the first time I run it, it works a shocking amount of the time. Like way, way, way higher than in any other language. But it also comes with the cost of if you're trying to like just poke and prod, which is how I tend to develop, it does make that kind of like a pain sometimes. So like the simplicity of a language like Zig is nice, or C is nice, where you're just like, just get out of my way. And like it's like when I'm writing Zig, I don't feel like the language is interesting, but in a good way. So I think that there's something about that, and it also feels like it has a lot over C that makes it good. Like the defer blocks, comp time, and just like their general approach to safety in general, those all feel very good. And their interop with C is like, holy shit, the best of any language I've ever worked with. So all of those things make it just like kind of nice. Seems like everyone hates C++. Even you just dislike C++ for lack of safety. For me, it's not safety. I don't really give a shit about. Well, I shouldn't say I don't give a shit. Like the thing I hate about C++ is it's insane. Like they just make so many bad decisions, like all the fucking time. And maybe that's just like, you know, what's it called? Confirmation bias, where you like you see one thing and then you keep seeing it over and over again. But just like you know, the fact that they made stud variant as their sum type, dude, like just look at this thing, stud variant. Look at, so, you know, in Rust or Zig, like the same thing to do when you want like a union, like a tagged union, is to add it to the language and add switch semantics to it. But what they did was they were like, well, these guys at Boost, they made this like crazy template system. So we accidentally made like a Turing complete template system, and people started doing like wacky shit with it, and then we embraced it. That's how I feel about like C++, and I feel like that was like a big mistake. And so like in order to use this thing, you create these like visitors where you, instead of doing something sane, like switching on something and saying if it's a double, if it's a string, do this, if it's a double, do that, you pass in lambdas to this visitor function, who then goes into like this. Their example here uses this like, look, what the fuck is this? Right? Like class overloaded takes a bunch of t's, and then you use those t's within the class so that you can pull out their operators, and then you have this like base case here, I guess, and then you can call this visit function with 3 lambdas passing. It's just like, what the fuck are we doing? Right? Stuff like this, or like stuff like async. Stud async by default is not asynchronous. So like you call a function stud async and you just get this thing that doesn't run until later. And then it gives you back like a future. And when you use the like if you have like a stud promise, this thing returns a future. And the idea is that you say like, hey, promise. You have a promise and a future. You give the future to someone, and you say, hey, later I'll give this to you. And they can like say, hey, future, are you ready? And the promise says like, nope, I haven't pushed it anything yet, so they don't get anything. But if you like drop that future, then like you just go like, okay, I don't give a shit. I'll look at it. So you do whatever the fuck you want. I don't care. If you call stud async though, it gives you a future. And when you drop the future, it blocks the thread until your async is complete. What the fuck? If you're just like, how do I fucking run a thread? It's like you would think that running something called stud async would give you a reasonable thing to do something asynchronously and not care about it. Nope. Like there's just so many fucking foot guns. Or like, what else? Remove if. Dude, this remove function, stud remove, doesn't remove stuff from your vector. So if you take like a vector and you pass like an iterator to remove, and you say like remove elements that are equal to 4, instead of removing them, it will swap them to the end and then invalidate the memory. And then you have to resize the vector at the end instead. Like, what the fuck are we doing, man? Anyways, sorry, we're getting a little bit worked up here. Stud move doesn't move stuff. It just casts it to our value. Like, there's just so much stuff where it's like, why are we doing it like this, guys? Like, what are we doing? Right? So when you say like safety, that's not really my problem with C++. My problem with C++ is like, just nothing works the way you would guess. Daily C++ rant out of the way. Well, yeah, I should stop, because it's like I'm saying the same things every time, but god damn, it pisses me off. What we're doing, we're looking at our like render loop. CPP without a CL is good. It's like, okay. It's like, I still do, like, even just writing a class in C++ is like fucking hard, right? Because like you need like we have like rule of 5 where if you write a constructor, if you write any non-trivial class, like just figuring out the semantics of when it should be destructed, what you have to do when you move it versus copy it, all of that stuff is just hard. It's just hard. So even without SQL, it's like it's just a complex language, and I don't think it's worth it. That rule of 5 makes no fucking sense. Yeah, I mean, it like I feel like it does once you like really boil it down. It's just hard to like you really need to like understand the memory model like really deeply to get it right. Okay, let's make our render loop. So what are we doing here? We, in our main loop here, we're saying, hey, if it is time to update the frame, update the frame. So maybe having some sort of like push or swap frame where we take in a frame and we return void. This is basically going to do this stuff where we like take the YU v-planes and bind them to our textures. What's up with the Zig hype online again lately? Yeah, I don't actually know. I don't know. I saw somebody in my chat a few months ago was talking about a Zig project. And I was like, damn, I've been meaning to work on like try something with Zig for like 6 months. And then I just started trying. And then right after that, I noticed like online, I started seeing all sorts of like Zig hype again. I'm like, oh, that's like kind of nice for me. Like a good coincidence that I started at just the right time when everybody starts caring about it again. So I don't really know why now. I don't know why now. So here we're trying to take in a video frame, which is currently defined in main, which kind of indicates that we should split out a like decoder file as well. So this like video, all of this stuff should go over here. And then we say const decoder, so you can say import decoder .zig like this. And then in here, I guess here we have to be careful with name collisions, which is fucking annoying, but whatever will live. This guy needs to be public. This guy needs to import C and std. Like this. Okay. And then that means that in our whatever we were working at on the GUI, he should now be able to say const video or const decoder is equal to import decoder.zig, and he should be able to say const video frame is equal to decoder video frame. Boom. Probably this guy has to be public. And probably we need to mark some of these guys' functions public, which they already are. So we're chilling. We're chilling. Okay, so here he says, hey, I'm going to bind my textures. We're chilling. And we go back to our main loop and see what else he did. Then all of this stuff is the actual render loop. So he needs a reference to his window, which we don't have right now. So window, we have a C. Well, what is the window type? Here, glfw create window, which returns a glfw window. Like this. Boom. And so this becomes an error defer where we do the actual destruction down here with self.window. And then our render loop now can use self-window down here. Width, we need to have our width and height defined in our loop here. Boom, so we can extract the width and height of the window. You think if ffmpeg was written in Zig, it would be better? I am kind of against the concept of, how do I say this? I don't think language matters. So saying like we need to rewrite ffmpeg in Zig or we need to rewrite any program in Rust, I think it's like a waste of time, personally. Right? We have I think FFmpeg is like, there are things that are not great about it, but I mean, there's a reason everybody fucking uses it. And it's because it works fucking good, right? So I think being like, it would be better if it was written in Zig. I don't think that's necessarily true at all. I think use whatever you're comfortable with. You know? FFmpeg is hard because it's video stuff is always hard. Yeah, I mean, I think that it's there's just there's just a lot of complexity, a lot of conditions, a lot of things to deal with. I think you're right. Okay, everywhere we said image, this needs to be turned into frame now because that's what we decided to name it this time around. Talking performance-wise, I don't think that this. I think in any language like C, C++, Zig, Rust, I don't think that your language is never the bottleneck. I don't think. I guess in Rust, you could argue that circumventing the safety checks is kind of hard, and so it makes it harder to write more performant code. You could make that argument. I don't know how true it is. But yeah, I don't think you, like, if you're talking about speed, you're, like, C can do anything fast enough. Like, that's my understanding, at least. Is FFmpeg not, like, 10% assembly? Okay, sure, okay. I could see that as well. When you gotta drop down, you gotta drop down. I can see that argument. Okay, how fucked are we right now? Surely we didn't do a lot of stuff right. Right, we haven't like updated our main loop yet. So in our main loop now, this texture binding is going to be replaced with a GUI swap frame with image. And then all of this stuff is replaced with render. And then here we have this like edge case where we say, hey, we want to close the thing. So we should expose a should close. Like this. And expose a close. Or set close or something. And we could continue using GLFW's should close, but I don't really know why we would. I guess we could. Yeah, I guess we will, because I don't really know if this has like other things associated with it that we might want to use. So return. This is not equal to 0, and set close. We'll call this. All right, and so now our main loop just looks like, while our GUI doesn't say we should close, do some stuff. We don't need this width and height anymore. We check the time, we update our frame, and then we render, and then if we want to close, we close. All right. Window is equal to window. And surely this won't compile. Decoder.zig not found. Oh, fuck me. I put it in the wrong folder. Wrong folder. There we go. There we go. Zig build. Decoder has no function named next. In main.zig. Oh. It's because this is called deck now, because decoder is a used name. No field named should close in GUI. Because I named it should without an L, so I can't fucking spell. This is not C set close, this is GUI set close. And set close returns a bool, but that's not true. All right. We don't work anymore, so clearly we fucked something up. Swap frame image resulted in a seg fault because GLFW is not initialized, which is confusing. Because GLFW should have got initialized here. Oh, because we said defer GLFW terminate, which is not true anymore. So we just immediately shut ourselves down, but we should be doing this down here in our dinit. There we go. Okay. Pain in the ass. A little half-hour detour, but Not the end of the world. Not the end of the world. Okay. So now that we have our abstraction, we can start getting a little bit more complicated in here. So let's get status, get format source, zig format source, get add source. What's in here? Nothing crazy. Get commit -m, GUI split out. Okay. We'll maybe clean that up later, but for now, good enough. I guess while we're here in like splitting out GUI stuff, actually, let's move our shaders out of being like inline because it's fucking annoying. Somebody was like, nagging me about it yesterday, and I was like, shut the fuck up, it doesn't matter. But it would be nice to get these into like proper GLSL files. So we can say source, GUI, I guess it's makedir source GUI, and then we can say source GUI vertex GLSL, and we'll just take this shit and shove it in there. Like this, boom, boom, and we'll edit source GUI fragment GLSL, and we'll shove this fragment shader in there. Boom, 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 boom. There we go. And then here we can, wait, what the fuck was going on here? Vert shader source goes away, frag shader source goes away, and this just becomes embed file of GUI vertex GLSL. And this just becomes embed file GUI fragment GLSL. He doesn't like that, probably because I need to just shove a little like ampersand on him or something. No, he still doesn't like that. Where do I want to put constants here? Maybe here. Const vertex shader is equal to import or embed file GUI vertex GLSL. Okay. Oh Lord, he did it. Yeah, you were bitching yesterday. And I do, now that we are moving things around, it is the time, I think. So we need to maybe say that these are going to be C pointers. And then hopefully that allows this cast to work the way we want it to. So we should be able to say, and vertex shader, and fragment shader, zig build. Not yet. Expected this const consuate found const cuint. Oh, because I was supposed to write for fragment shader as source here and vertex shader source here. It can accept multiple shader units, so it needs to be an array of source files. Ah, I see. Okay. I think we're chilling. We're chilling. Get add source, get status. Get commit amend. All right. So let's look at fixing that green bar on the side. So, right, the stride that's coming out of the data in FFmpeg is not equal to the width of the image. So, right, like, I don't know exactly why FFmpeg is choosing to do this. But it's kind of just saying that when I decoded your video, I allocated some buffer of this width, but the data in the video actually only made it up to here. So I just like didn't touch whatever the fuck was in this stuff. I don't really care, and I just filled in these pixels, and then it's up to us to cut this shit off later. And the reason why it's not like super trivial is because if you wanted this to be contiguous memory, you would have to like copy it out into a new buffer. Gross. So what we're going to do is we just leave this shit on here, and then when we upload it to the GPU, we say to the GPU, hey, can you just like, when you map this input to the screen, just like discard this stuff, is what the plan is. Which means our fragment shader, or our vertex shader, one of the two needs to take in like a width ratio. Maybe I think we'll do the fragment shader. I think that works for me. And then we just multiply everything by width ratio. Which means that when we extract our frag chord here, frag chord.x times equals width ratio. And then all we have to do is when we swap the textures in, I guess we will set that value in our program. I actually don't know how that works. I don't know how that works. When you are in your OpenGL render thing, like when I say, if I were to go into here and say like, hey, can we bind program? What's it called? Use program. If I say, hey, we're using our program, and then we want to say set uniform float, where we also have to get the position, GL get uniform position, which probably we should actually be caching. We probably shouldn't be doing this every time we use it, but fuck it, whatever. So say width ratio lock is CGL uniform 1F, or sorry, GL get uniform location of width ratio for our program. Is that in the right order? Yes. Then we say, hey, I want to set the width ratio to the frame.width over frame.stride. So we can say here, const width ratio is equal to frame width, which I think is currently a usize. So we say float from int like this. We make this a var so that we can say width ratio divide equals float from int frame stride. And doing it in these two steps makes it so that I don't have to like deal with like setting up these float casts everywhere. I think this makes it simpler. We'll see. That's my hope, at least. So what I'm not really sure about here is if I do this and then another program goes and he uses a program and sets his uniforms, I don't know if they're like sharing the same memory, right? You could imagine like two memory models here where either you have like program memory, right? And in here, you've just set like width right here. And then you could imagine that when you swap in another program, it could reuse the same memory. So if they just happen to have another thing that they write at this location, does it overwrite? Maybe. The other model which would make sense to me is if they had prog2 mem over here, and when you typed GL use program, it switched which one of these guys it's pointing to. I don't know which one of those is true. And so I don't know if doing this here is like the correct way to do it, or if we should cache the width ratio in our program at this point and then assign it down here when we're setting up our program. Maybe I'll do it that way either way, because that way like that works in either case, and also it makes it really clear where you're setting shader program parameters. It's not like spread out. I'm okay with that. So we will make this a float. And then just wherever we were doing this stuff, we'll just say self width ratio is equal to this. We'll do self width ratio is equal to this, and then we divide equals it like this. And then down here, when we are running the program, we say uniform 1F, get the location, and assign it self width ratio. And instead of learning, now we've just managed to dodge the problem. Hell yeah. Width ratio 1.0. There's an LSP for GLSL and Mason. I'm not really too concerned about it right now. The GLSL programs are so simple that it doesn't matter. Okay, so that's good. Stride, there's no more green bar at the end. It is kind of leaking in there. I don't know if you guys can see it. Is there like, I don't know if this like shows up on stream, but there is a little bit of green bar there leaking in. So probably, oh, is it on the left as well, actually? It is on both sides. Do you guys see that zoom in? Yeah, you do. Sick. That's super cool. I could fix that right now. But I don't care enough. This is like we've gotten rid of like off by one error. Yeah, it's probably like chroma sampling off the corner in some way. Fix it. I think I will fix it another time because it's not like the green bar on the side was like really annoying to me, and this is only like a little bit annoying to me. You can imagine that it's like, oh, I've got my VR goggles on, and I've got some like chromatic aberration around the corners or something. Maybe you can say it's a feature, not a bug. But really just because I want to get onto other stuff today, so I don't want to rabbit hole too far. Could be because of the texture linear interpolation. Oh yeah, it could be. Yeah, that seems very possible. Very possible. Okay, so we're going to give a similar treatment to aspect ratio. So the aspect ratio is going to be checked on every frame. We have our width and our height here. So all we have to do is maybe embed the aspect ratio here. And so here we're going to set the aspect ratio to aspect ratio. And we have to make the aspect ratio, so we can say, what, const aspect, or var aspect, var, dude, come on, I can't type. Var aspect ratio is an F32, and it's going to start as height. Is it height over width or width over height usually? 16 by 9 is width over height. So this is float from int, boom, 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 boom. And then aspect ratio divide equals float from int height, okay. Then we set it, and then in here, we just, when we are looking up our coordinates, I guess we have to check if it's greater than or less than 1. Because where the black bars are depend on, like, which side we're shrinking when we look up, depends on if it's taller or wider. If the window is, this is the aspect ratio of the window, but we also need the aspect ratio of the image, right? Because if those match up, then we don't have to worry about this. So, which means we kind of have to store like the image aspect. Which we can get here. Self-image aspect ratio is equal to frame width. And then self-image aspect ratio divide equals frame height. Which kind of means that this is an aspect ratio. Yeah, right? Like how much do we need to adjust to get from the window aspect ratio to the image aspect ratio? And I like the idea of calling it aspect ratio. That's funny and true, so I'm going to keep doing that. And so we'll call this now window aspect ratio. And then the aspect ratio is equal to the window aspect ratio over the image aspect ratio. Okay, so if the window is too fat relative to... If the window is too fat relative to the image, this is going to be greater than 1, which means the black bars are applied on Y. So if aspect ratio is greater than 1, we are going to say that the frag core.y windwoe or window. I did type windwoe and I did notice that, and then I just didn't fix it because it was right, like it was used spelt wrong everywhere. So I was just kind of hoping nobody would notice, but you did notice, so fuck you, I'll fix it. So this is y is going to be divide equals by aspect ratio. And if it's less than 1, then we can multiply x by it. Wind, whoa. So C2FW, nice. A thing in my Twitch GUI just disappeared, which is a little spooky. I don't know if I'm missing something. Dude, fuck, so all software, not all software sucks, man. It's just like everything I use is always broken or slow or pisses me off in some way. Including software I write. I want to make it clear that I'm not, like, I contribute to the problem. But man, I just wish it was all better, you know? You know? We need to set the image aspect ratio here. So it'll default to 1.0 until we give it an image. It's fine. Okay, so we did fix, the aspect ratio is now correct, but instead of black bars, we're getting cropping, which is not what we want. But we do at least have indication that the aspect ratio is doing something. So maybe these are swapped. Maybe I multiply and divide is backwards. It is, and now the problem is that our texture is like repeating instead of like being centered in the window, right? Oh no, hold on. This is no, that's wrong. That's wrong. This was like correct aspect at least. So let's use our brains instead of just changing numbers and guessing, right? Instead of just multiplying numbers together, we could think about it. So our vertex, or like vert chord 2D, is going to be 0 to 1, 0 to 1. Sorry, brains on strike. Flip the X and Y. Okay, fine. Instead of thinking, we will just try randomly flipping X and Y, which I think is probably right, actually, now that you say it, but, oops. This should be, you mean flip this. Yes. Okay, that is what we want. And now the problem is that instead of it being centered and being blacked out, we end up with just like repetition here. So we need to figure out how to center and black out. So I guess here, if frag chord X is greater than, or is not in the range of 0 to 1, I think there's a thing you can type here called discard. Discard, I think. GLSL discard, which says like, hey, I'm not going to output for this pixel. Don't use discard on fragment shaders. That's interesting. It is hardware dependent. So maybe, I guess the other option is I could just set it to black. But I just want to know what the syntax is. Give me a example. Discard, return. Discard. Yeah, I don't know why it's not highlighted. I guess because I just don't have something installed that I should. And then here we just have to do the same for Y, so. Let's try that. Fuck. Oops, because I wrote 0 everywhere. So this is just evaluating to true unconditionally. We could write 1 like we intended. Still nothing. Interesting. If frag chord X is less than 0, or frag chord X is greater than 1, or frag chord Y is less than 0, or frag chord Y is greater than 1, discard. But why would this be discarding everything? Can I just return instead? We'll just leave it. What am I missing here? Can we do something like to debug? We will set the fragment to vec4 frag chord X frag chord Y 0 1.0 and then return. So this should because Y is inverted, maybe? Yes. So this should be 1.0 minus frag chord y. Okay. So what was happening there is so our image coordinates are 0, 0, but the fragment coordinate, the fragment shader coordinates are 0, 0, or vice versa. I don't really know. One of the two. So this is like frag, and this is image. So what we did was, if our frag coordinate was at like 0.2, we were like, okay, we'll just flip it. So we were down here at negative 0.2. And then because the texture was like repeating, right? He's like the same thing over here and over here. This would like end up effectively being the same as 1 minus 0.2 because it would like shoot itself back up to this one, right? Or sorry, this, you get the point. This negative 0.2 should probably be drawn up here, because what he's trying to end up at is 0.8 up here. He's trying to flip over here. So instead of just negating it, I do 1 minus, and I think that should do the right thing. So now we should see, at the very least, something here that might make sense. I'm honestly not sure here. This is going green to yellow, left to right. I don't know what's with this, like, red here. Something about that I'm not sure that this is correct. I'm not sure that this should be symmetric. But we will see. We will see. Yeah, something here is wrong. Look at that. It looks trippy. So what did I do wrong here? Oh, oopsies. It's because I times equaled instead of equaled. Ah, that's much cleaner. So let's see what that was supposed to look like with colors. Just out of curiosity. That was supposed to look like this. This was what we do. We did frag chord x, frag chord y, and then 0.0, I think is what we did. Yeah, that looks way more reasonable. So hard green at the bottom, dark at the top. That makes way more sense. It's also seems to be non-linear color mapping. Or we're going over 1 the farther we get down there. That's probably what it is. It's probably supposed to stop somewhere. Like, you can see like a hard line where the video 16:9 ends. Okay. So we're chilling here. We have the image or the video playing with the correct aspect ratio. It's just now we want to center it. And we also want to make sure here that this gets cut off. So we actually want to discard here if x is greater than width ratio, so that we don't end up showing that memory when we end up too far to the right. So better for sure. And then the last piece is centering. So I guess we are looking up, we are given a pixel in, we are given, this frag chord comes in, and it's in like 0 to 1 for the image. Sorry, it's in negative 1 to 1 for the image. So here it's 0 to 1 for the image at this point. This is frag chord is in the range 0 to 1. Kind of, probably-ish. Close enough. Now, if we are trying to center, what we need to do is we need to adjust this coordinate to match. So it's like, if the aspect ratio is less than 1, that means that its height is bigger, which means that we're adding black bars to the side, which means that frag chord, is that what this means? If the aspect ratio is less than 1, we are squishing the y coordinate. So the top of the window will get to the bottom of the window slower. What does this mean? So if we're in the range 0 to 1, and we say aspect ratio is equal to 0.5, this will end up, frag chord is in the range of 0 to 0.5 on y. X is untouched, which means that we are adding black bars on y, which means that fragcore.y needs to be moved towards the bottom of the screen, which I think is a minus equals, by aspect ratio over 2. And then x is going to be the same, but add? Maybe? There's a really good chance I got that wrong. Yeah, there's something wrong here. The size of the bars in y depend on x. If the aspect ratio is if the aspect ratio is, I actually don't know here what the aspect ratio is, to be honest. Window aspect ratio is small. Aspect ratio is big. So this is a very small aspect ratio. So which does feel like this is right. Okay, let's only work on like x right now, just so that I can like build a better intuition. Okay, so here we immediately flip into this case, and that's doing something wrong. Is it that this is supposed to be subtracted? Because it's like if you have a piece of paper in a window, are you sliding the paper or the window? It could be this way, and then it could be that I have to do this movement before I do the multiplication. Okay, no. Let's just, So this needs to be moved by some amount, which is half of the size of the black bar, which is what? What is half the size of the black bar here? So at some point, this is 1.0. Is that still true at this point? Is that still true at this point? Here we multiplied x by width ratio. So it's actually more like this is 1.0 at this point. Okay. So this is not the point of case. Now we need to move it. We also know that, so this is anything greater than 0. And so we need to find out what like the max value would be here. So the max value here would be aspect ratio. This is APP. So we need to add in, this should be aspect ratio, aspect RR, ARR, not APP. So this would be aspect ratio over 2, but this would be 1 minus this. Aspect, no, the other way around. Minus 1. Hell yeah. Oh, no, fuck. So if I understand correctly so far, this should push it to the right side instead of the left side. Let's see if that's true. With no division. It's going too far, actually. And a smaller number here, is it like width ratio because of like this like bullshit that ended up getting applied to it earlier? No. I don't understand why it's moving too far. So we have, would you make this have some features like it has on Sony Vegas Pro? I might use this app I've been using. If so, because I've been using Vegas Pro since like 2020. I don't know what that is. So who fucking knows? I'm going to write exactly whatever I feel like writing is about the extent of it. So no promises on anything. No promises on anything. So here, aspect ratio is greater than 1. Width ratio is ratio relative to stride. Okay, let's take out the width ratio stuff first for a second, just to simplify this. So now we can just think about 1.0. So if... Yeah, what the fuck is going on here? Not gonna lie, aspect ratio is the worst variable name. It's pretty bad, for sure. And then I want to get rid of this discard as well. Just to help my brain function a little bit. Simplify the problem. Yeah, I don't understand. I don't understand. So it must be that, like, aspect ratio... So we expect this to be in the range of 0 to 1. Pretty sure that that is true. Now, if the aspect ratio is less than 1.0... Oh, 1 over aspect ratio. That would make it bigger than 1, like we expect here. And then a plus, maybe, instead of a minus. There we go. It's hugging the right side now. There we go. There we go. Okay, so I think that this diagram was correct to some extent. It's just that this is a 1 over aspect ratio here. Okay, so now we can say, let's add back in this width ratio stuff to make sure that it still does what I expect. Oopsies. Width ratio. And so now we should see the green bar go away. Nice. And he's still hugging the right side pretty correctly, I'm pretty sure. And now we just have to divide this by 2. All right. That's not bad. I'm actually not... There's something wrong here still. This is probably related to the stride stuff. So this 1.0, is this supposed to be width? 1 over aspect ratio minus 1.0 minus width ratio? Width ratio is going to be like 0.8 or something. So maybe it's just like this. Minus... It's like minus 1 minus 1 minus width ratio, so... Right, like... Oh, yo, 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 yo. Maybe better to multiply by width ratio after bounds check. I could see that. Yeah, that just makes everything kind of simpler. So this becomes 1 over aspect ratio here. Here we can use 1.0 here, and then we squash it like this. Except this plus equals has to happen before... This plus equals has to happen before the scaling, I think. Okay, so let's draw this out again. I don't know what to change here. We have aspect 1 over aspect ratio here. I like code. Am I welcome? For sure. Of course you're welcome. Of course. We're struggling right now, but maybe that will make you feel better about you not struggling or you struggling. Okay, so X, he says, hey, times equals width ratio. So that means, this is backwards. This is, hold on. Okay. So we have our image. It comes in with this being 0 to 1, 1.0. We then multiply by width ratio, which means that this is now, since it's below 1, this is now like 0.8. Okay, which means that the 1.0 extends off the screen here, and effectively the stride is getting mapped into this off-screen section. Now, when we try to add this like black bar stuff, we're still working in relative to 1.0. So we're working relative to this. So we should be working relative to this 0.8. So this being subtracted by width ratio makes a lot of sense to me now. That sounds correct. But it's clearly not, because we're clearly we're stuck, we're like too far left now. Oh wait, but also this stuff has to be this like discard now is in the wrong spot, which is probably fucking with stuff. Let's turn this discard off. Add hot reloading and tweak without restarting. I don't think there's any need to. I think that's just like a lot of extra complexity. Like how long does this take? Like no time almost, right? Like a full recompile and run here is like 1 Mississippi, 2 Mississippi. And it's not like nothing, but it's not a lot. Shared hot reloading is sometimes nice. Yeah, I can see it being nice, but I don't think it's worth it here. I don't think it's worth it because it's not like what's supposed to be happening here isn't supposed to be like art. It's supposed to be math. I'm supposed to fucking understand the numbers I'm working with, which I clearly fucking don't. Now it's centered when you include the green boundary. Is that true? Oops, not now. The green boundary isn't there, so that was with this commented out. It's centered when you include the green boundary. I don't think it is. Oh, maybe it is. We are seeing almost exactly 3 of them, which does kind of indicate that it is centered. It's just hard for my stupid fucking human brain to figure that out. Yeah, so we just need to scale something by the width ratio. Which we were already doing? Because aspect ratio, hold on. Aspect ratio is relative to the image aspect ratio, which is relative to the image width, not the image stride. Which means that there's probably another no, I'm missing something. I hate everything. Okay. 1 over aspect ratio is the without padding image over the window size. So if we are at a perfectly 16:9 image, this will be 1. Right? Let's just start there. If this matches, this will be 1. So now, in that case, we want to do fucking nothing. That seems reasonable to me. Will be easier to see this type of thing without the texture wrapping, no? I think, to some extent, maybe, but I was commenting out to clear something else up in my head. So if this is 1.0, we should subtract 0, which means that this should be 1.0. Right? Okay. So now, what if the aspect ratio gets bigger? We should subtract something. Like, is it just, I shouldn't be dividing by 2 here? No, clearly not. So this is, yeah, this is scrolling too far. Where it's not hugging the right edge like I would expect. So what did we have before where it was hugging the right edge good? frag chord x plus equals I wonder if we have to multiply this by the width ratio. Or divide it by the width ratio. Both of those seem like possible answers. Aspect ratio minus width ratio over 2. Would that make sense? I feel like, what am it's so hard thinking about this stuff backwards, I feel like. I feel like when you're working with transforming coordinates, all of the things work backwards from the way I would expect, right? Like, because I expect, I'm trying to move, like, the image to the right, but that means I have to move, like, the coordinates to the left. And if I'm trying to make the thing fatter, then I need to make the coordinates fatter instead of the thing itself. So it's hard for me to, like, wrap my head around it sometimes. But okay, let me see if there's, like, a way to draw this out where it makes sense. So there's something about order of operations wrong, the missing parentheses. It's possible. So we go 0.0 to 1.0, and we then turn this into, we then map the image into something smaller than this. Okay, so this is like 0.0 to 0.8. Then we say if the aspect ratio is less than 1.0, the aspect ratio is the window aspect, which is the window width over time over the window height, divided by the image width over the image height, which turns this into window width times image height over window height times image width. Just writing that down because it might help me in some point. So now we are saying if this is less than 1.0, we are trying to, essentially we want to shift this by 0.1 is like the goal here, right? Which is, no, that's not true. That's not true. That's not what we're trying to do. We are basically trying to get it so that this 0 to 0.8 is centered in the range of 0 to 1 over aspect ratio. Is that true? And then all of that scaled to 0 to 1? Which means that we have 1 over aspect ratio minus 0.8 is the distance that we need to travel over 2. But then all of this needs to be scaled in the range of 0 to 1 or something. There's something about this that doesn't make sense. This is me working in, like, wrong coordinate systems, I feel like. God, I hate this shit. It's so frustrating. It's like, the concept is so fucking simple and I just can't fucking get there. So I want to take the width ratio stuff out again because I feel like that will help. I want to reason about it again. And in that case, it was just something like this, right? If I remember correctly. Like, here we had it. And so the only problem is with the ratio mapping, I'm struggling. So like, I don't understand why, if, like, everything worked in, like, the range of 0 to 1 before, why this isn't working now. multiply x by width ratio map from 0 to 1 to 0.8. I do feel like that's true. Like, what I don't understand here is if this is working at this point, how come if I just rescale my x coordinate system to be relative, to make it so that like the image takes up the right amount of space, why this doesn't work anymore? Right, because in this coordinate space, after here, we should have 0 to 1 is just the width of the image. To me, it looks like it would be centered if that green bar was split in half of its current size. It's so hard to, like, see here. Container width minus image width over 2 equals x if you want to send an image in the container. Yeah, I mean, it's clear, like, we clearly have that when we're not scaling the width. Right, this is perfect. But I'm missing some obvious thing where scaling this guy by image width before the centering is causing this to change behavior, and I just don't understand why that is. Because I would think that doing this, nothing should fucking change. Now scale after clipping with the black. I wonder if it's like... Well, we could just undo something here. Just to see. I don't think that should do what I expect. Or, like, it shouldn't do anything reasonable. No, it doesn't. Of course it doesn't. But there's something where, like, this is playing and I just don't understand. I know that someone in chat might be explaining it in a way that's correct, and I'm just not getting it. That might be centered. That might be. That's correct now. And so this is now, if x, we need to handle the clipping before we do the width adjustment, I guess. No, that's not true. We have to do the width adjustment, then clip at the end. So this has to be if x is greater than something. So we'll maybe make a float x offset is equal to 0. Then we say x offset is equal to this. And then this plus equals x offs. And then we can say if this is greater than or width ratio plus offs. And if this is less than or equal to x offs. That should do it. But I wish I understood why. Oops, fucked up. What isn't it like? We can do 2 and 1 head dash n 20 or something, or 10. Unexpected identifier at line 29 in this guy. I forgot to put a semicolon. Clipping is wrong now. Clipping is wrong. Oh, fuck me. Is it related to the order of operations here? When I multiply by aspect ratio, well, let's not touch it too hard. Let's not touch it too hard. Because I don't really understand it fully, and just that's gonna end up in a bad spot. What the fuck? My x offset is this. I added that thing. Divide equals there, maybe? I'm gonna lose my fucking mind. I feel like it's so simple. If... Oh my god, so here x bounds should be 0 to... Oh, the random garbage might throw it. You're right, I did mean to type discard here. That's a really good point. Yeah, it's just clipping too far to the left now. Oh no, we should be able to do this discard up here, actually. I'm back to believing that. I am back to believing this. I could be wrong, but we'll see. Yeah, that discard's just doing nothing. Right, because we want to know if after all of our mapping... Right, because if we were to do this, like, here, this would basically just discard nothing on the screen. So we need to understand where is the region of interest of everything after all of our transformations. And so we need to know where the image is expected to start, which we can find out. We can find that out. Right? It depends on the x offset. So x offs. Let's just see if we can get it to hug the left image, the left side of the image here. And so here we say our x offset is this thing. And then we multiply everything by the aspect ratio. Which means that this should also be multiplied by the aspect ratio. And so if this is less than x offset, it should be nothing. Or it should not be in the... But then that's clearly not happening. Oh, wait. It's happening over here on the right side. Oh, no, that's okay, because of the 1.0. So what's... Is this negative? 1 over this minus 1.0. So aspect ratio is less than 1.0. So flipping it should be greater than 1.0. So this should be positive. Is it possible it brackets? Like, why is this not getting... Like, am I fucking high? If the fucking x coordinate is less than the x offset, then we shouldn't fucking be displaying it. What is this x offset? It must be something less than 0, right? Like, if we put this at, like, 0.5, we should show half the fucking screen, right? Am I fucking high? That's not half the screen. Okay, so I'm working in the fucking wrong coordinate space again. Which would do it? Is it just 0 here? Oh, god damn it. It is just 0. Is it because I scaled 0 to 1? Oh my god. Dude, everything's so fucking hard. There we fucking go! Dude. Oh, I'm so mad at myself. I'm so mad at myself, but it's okay. It's okay. It's okay. Okay, now let's just see if y gets centered if we do the stupid simple thing. And it's not. So what did we do with x here? We did aspect ratio minus 1.0 over 2. There's no width ratio mapping to be done on this, so this should be easier. And then we did a plus equals down here. So doing a plus equals over here also probably makes sense. That doesn't look centered to me. Yeah, it's definitely not. Oh, okay. Let's try not minus 1.0. I don't remember why that 1.0 is there. Okay, so that looks centered to me. And let's just do the clipping now. Or frag core.y is less than or 0. Or frag core.y is greater than equal 1.0. Okay. Please, please. Okay, so we are just looking at the one at the top. Why is this doing nothing, it feels like? Are we seeing the whole video? Oh, it is shifting the wrong way, maybe, it looks like. What is line 31 even doing? I think that this is applying the same aspect ratio scaling to X offset, which actually is not needed. X offset is just not used anywhere now, so it's kind of useless. Kind of useless. No. Because this has to be float here. Okay, so what the fuck are we doing wrong here? Take out this discard again. And let's see if we believe that this is getting, like, scaled relative to the top left corner, it feels like. I'm going to take out this addition completely. Because clearly it's not doing what I expect. Here it is doing what I expect. Here it's just sticking to the top left corner. And repeating itself below. Okay, nothing fucking crazy there. If we add just unconditionally, oh, here we did the adjustment before aspect ratio adjustment, so here maybe we have to do the same thing. Still no good. Okay. So let's just do something stupid and add 0.5 unconditionally. Just to see what happens. I don't really even know. You still don't need the -1, I do think. I also think that. I think that it should be y offset is just this. And I think it should be frag chord y plus equals y offsets. But I just was trying to, like, reason my way around it, and that's clearly not it. Wasn't this working before and just clipping was wrong? I don't think y was never centered correctly. Can we do something like if we show instead of the image? No, that won't work. Let's re-enable the clipping. So it looks like y is moving the wrong way. So this being a minus equals seems to make sense in some way, shape, or form. And now he's moving too far. So this 1 over aspect ratio over 2.0, I've missed it here. He's still going too far down, which makes me question this minus. Oh, this 1 over aspect ratio is not correct anymore because it's the other way. Okay, now he's just not moving at all. Oh, no, he is. He's going up now. Flip the sign. Just, you know, randomly touch it. And there we go. We finally got there. I wish I could reason about why this was correct. It's really pissing me off that we're, like, guessing and checking here. It's really pissing me off. I feel like this should have been way easier, and I feel like if I understood the math better, if I had a better mental model, this wouldn't have been hard. But instead, because I was just like fucking lost, and like we're working with this like aspect ratio concept, like this actually looks pretty straightforward, right? Aspect ratio minus 1.2, that's the difference between how tall the window is and how tall the image is halved. That makes a lot of sense, and I just don't know why it took me so long to get here. This felt, I still don't understand why this width ratio has to be here. But we're there, and I don't want to spend more time on this than we have to. I'm going to think about it more off stream probably. But for now, I think we're going to call this done because I don't think it's fun to watch me go, fuck you, fuck you, fuck you, fuck you, over and over again, you know? But yeah, feels good. Feels good. That it's right, at least. Is the video just low quality? Yeah. It's a 320 by 180 video. I picked the smallest one on their website. Okay. Aspect ratio. So the next thing I wanted to do was support some form of like pause play. Why does it think this is returning a Boolean? It's weird. LSP restart. So I guess if we were trying to pause play, it means that our GUI needs to tell us that a button was pressed. Right? So we need to do something like pub function get keys, get input. Okay. And he's going to tell us something. We don't know what yet. And we can look at like maybe glfw hello world. And it will tell us how we interact with the windowing system. Oh, does he not? There's no input handling here? glfw input handling. Is there just like a key press thing? Gamepad input, joystick, mouse button, cursor. I just want to know like when space is pressed. Text input. I guess it's kind of text input. Key input. If you wish to be notified when a physical key is pressed, set a key callback. Okay. Okay, keyboard input. Yeah, so we just set a key callback. Well, so I guess this is like super event-based. Is there a non-event-based version, just out of curiosity? Just out of curiosity. Returns the last reported state of keyboard key for the specified window. Okay. So I could just check, hey, is it pressed? But I guess asking, is it pressed, is not really fair unless it will tell me if it was pressed this frame. So I wonder if this is fine. Right? We could make an argument that we are rendering every frame, and so we can just process the events that happen between frames. It really depends on what the time frame for this is. But I would assume it would be one frame. Like, it would be silly for it to be anything else. So we'll try that for now. But then we have to like cache stuff and stuff. Maybe the event-based system is better. So what does like the event-based system look like? The event-based system is, hey, glfw, could you call this function when a key is pressed? So we can register something like this. And then what will we do? Our caller is going to say, hey, was a key pressed? I guess the question is, what is like the abstraction here? The abstraction is probably not that the main loop should care what key was pressed. It should care that there are things to do, right? The GUI is going to say, like, hey, could you pause the video, please? Please? Hey, could you seek to, like, probably, like, 1/10 of the way in, he probably will know the timestamp. So he's going to say, hey, could you seek to 5 seconds? Hey, could you play the video? Right, so maybe we will ask for like get next input event, and maybe we'll say like input event, which is like maybe not quite the right word, but I'm willing to use it. Where this will say like actions. Ooh, if I'm gonna say action, that makes a lot of sense. Get next action. Yes. So this is going to be like, what does the GUI want us to do? And he's gonna say pause. Why not just set a bool and call your self-made function is paused? Because that's a good question. Why not just do that? Because I'm thinking about later, which is maybe the wrong answer. I think that, it's because I don't necessarily want the GUI to handle the state of whether or not we should be paused or not. That's what it is I want the GUI to tell us that it wants to be paused, but I want the state of whether it is actually to be paused, like whether it is actually paused, to be controlled by someone else. Because I'm like thinking of the GUI as like someone who displays the current state as well as requests changes, but is not the owner of the state itself, if that makes sense. I like some of these, like it was hard for me to articulate that because like this pattern is kind of like embedded in my head a little bit, so I had to like what's it called? Rederive? Like when you when you like look at a math formula and you like figure out how to get to the math formula so you don't have to memorize it, but then you like memorize it anyway, so you have to be like, oh, I know I could get there if I had to, but it's just like this thing I believe now. Okay. So he is going to say, hey, we have an action to do. And it's going to be like, if pause, if space pressed while paused, is that how we want to handle this? Like if someone spams space 4 times and like the GUI is like, the application is blocked up in some way so that it didn't actually process the pause, do we expect that the space action is going to toggle pause over and over again? Because I was also kind of thinking like it would make sense for it to not toggle. Okay, so maybe this is going to be like toggle pause is what he's going to ask for. What are the enum ways in this language? Toggle pause, yeah. Toggle pause. And I'm expecting later that this will be like seek whatever. Or like step frame, etc. Like, so that's why I'm kind of doing this now, even though there's only one action. But we could maybe call this should toggle. Yeah, I'll just do this for now. It's fine. It's fine. So if the space key is pressed, we will push into some vector. Right, we need to do something like this, where we have like some set of actions that have been like requested based off of some inputs, and we'll just like return the next one. And presumably this callback, like I don't know if this can happen from another thread. Like when is this happening? You know, is all of it running the same thread? Yeah, that's exactly what I'm wondering. Like when does this run? It must, because like there's no like event loop right now, right? We're just calling like OpenGL calls and glfw swap buffers. So somewhere we must have to trigger. Here we go. So there are 3 functions for processing events. glfw pull events processes only those events that have already been received and returns immediately. This is the best choice when rendering continuously, but most games do. If you, oh, okay, so maybe this is just where we should have started. This might just make more sense. What does this do? This function, oh, it processes events and then probably sends them to the callbacks. If you need to wait for the contents, blah, blah, blah. Post empty event. So this was like unblock the thread. Yeah, so I guess we call glfw poll events. Which should go somewhere. Maybe like here. Maybe instead of calling this render, we can call it step. And then this guy will also be responsible for updating internal state. Right? And then at this point, we know that there's no mutex contention that we need to worry about on anything. Because we can assume that like anything will be called from within this function essentially. So we can just have actions, which we need some sort of like circular buffer, which I think this has. Or like linear FIFO might make more sense, probably. So this just lets us shove shit in and take shit out. So we can write a thing. Is there just no like push pop? Is this like too much? It feels like a lot. Readable slice. We can read item. And is there like a write item? Yeah, there is. Okay, yeah, fuck it, we'll use it. Sometimes I would be more inclined to write my own circular buffer, but not today. So this is going to be a linear FIFO who takes in a type. There's a ring buffer, but it doesn't grow. It doesn't automatically resize, I don't think. Yeah, which is the reason that I didn't want to use this. But I guess we could just use a ring buffer and allocate it to be big enough so that it never fucking matters. Maybe I like that a little better. Because I do feel like the linear FIFO is too much. So this is going to have like actions. And our actions are just going to have to be somewhere. So this is going to be stood ring buffer action init. Do I have to initialize it with some allocator? Probably. Init with an allocator and capacity. So here we will say we need an allocator then, which shockingly we haven't used this whole time. Which means that we have to say const allocator equals stood mem allocator. Boom. And so now we can init this thing with an allocator and with like 1,000 items or something. Who fucking cares? Okay. Then here our get next actions will be read, and it will return null automatically. So we just say return read, and does this automatically, this is like a pop? Consume a byte from the ring buffer. So surely this subtracts the read assume length. Let's see. Linked list. Boo, linked lists. Boo. I like the idea of everything being next to each other in memory, even though it doesn't fucking matter. Yeah, this does increment the pointer. Okay. So now all we have to do is on initialization, we have to assign our GLFW callbacks. It does matter for cache locality. Yeah, I more mean that it doesn't matter in terms of like this context, like the performance doesn't matter at all. Like is more what I meant. I understand that it does matter for cache locality. That's why I like it better. But like in reality, how much does it actually matter? Okay, so we have to assign our key callback. And the key callback doesn't take in a user pointer. Oh. Oh, that sucks. Can I assign user data to the window or something? Is there... Create window probably has... Really? Really? What is this thing called? It's called GLW set key callback user data. Set window user pointer. Okay, I can live with that. I can live with that. Which is a little bit tricky because our self lives on the stack, which kind of means that like this stuff lives on the stack, which means that like after we return here, we can't return self. So we have to return a pointer to self, heap allocate ourselves, so that the window, so that we have like a stable memory location in order to work like that, so that this key callback can point to somewhere. Unfortunately. Sucks to suck, but it is what it is. Var ret is equal to alloc.create. Dude, my brain. My poor little brain. Self. Alright. Error differ alloc.destroy self. And now the question is like, whose responsibility is it to free this guy? Like, it kind of makes sense for us to be responsible for freeing ourselves since we created ourselves. So maybe here we say alloc.destroy self like this. I think that's reasonable. I don't know if that like violates expectations of people writing this code, calling this code, but I am the person calling this code. So it doesn't violate my expectations because I wrote it. It's an easy fix. Okay. So now that we have that, we can... Were we trying to set the user pointer somewhere? By the way, I think const self equals this is mostly used for generic structs. I mean, it has to be used here because we don't know the name of our struct because it's like the root of the file. So we don't have like a GUI name to be used here. GLFW set user window user pointer. On the window, we can now set it to ret. And then we can set the key callback. Const GUI equals this. Oh, I see. I don't know. It seems like it doesn't like nitpicky. No offense to you. Like I don't really see why it would matter. I guess the expectation is that self is used in generics. I just don't understand why it matters. And so I will continue doing it this way until it bites me somewhere, and then I'll be like, oh, I get it now. Function key callback. What does he expect? Function name, key function. Here we go. So here we call this key callback. This is a function who returns void, and we have to say, hey, could you use the C calling convention? And then our inputs are going to be a window, which is a C pointer to a GLFW window. Boom. A key, which is going to be a C int. Scan code is going to be a C int. Action is going to be C int. And WADS is going to be a C int. Cool. So now we should be able to extract our struct from the user pointer. So we should be able to say window get user pointer. Who fucking knows what it's called? glfw get window user pointer. So we'll say const self void is equal to this. Then we can say const self is equal to is a pointer to self, which we get by pointer casting self void. He's probably gonna have to make some line cast that as well, but for now, who gives a shit? And so now we just say if he is equal to something. Somewhere space is defined. glw key space. Nice. We will say self actions. Really? Actions. Why doesn't he autocomplete for me? It's fine. It's fine. It's fine. It's fine. So there's probably right. Yeah. Right. Action, toggle pause. Okay, that all feels good so far. And then we just say scan code equal, this equals scan code, action and mods. Okay. Use of undeclared identifier, so this has to say c dot. This has to say window. All right, how fucked are we? I guess the last piece here is in main. We want to basically ask get next action. Fix me step actions should be requested before rendering, not using actions from previous iter. But it doesn't fucking matter too much, but it's fine. And then we can say, while this has some action, we're going to have to handle the action. But for now we know that the action is equal to toggle pause. And here we'll just say pause time, just so that we can see something working. I think you need to align cast the C pointer. That seems very likely to me. But I just haven't got there yet. I was gonna let the compiler tell me I had to. You know? So this is gonna be ret equals this, and then we return ret. We are now sitting in stood ring buffer is not a function. Stood ring buffer. What's the problem? Wait, how does it, like, does it not hold, it only holds U8s? It's not generic? Oh, god damn it. Oh, gross. Do I really want to... Oh, I just don't want to deal with it. What's a tail cue? Ugh. I guess linear FIFO is what makes most sense. Who takes a buffer type as well, which we will say dynamic. Okay, then here our errors can be also the errors returned by an allocator error. C pointers cannot point to opaque types. Why the fuck not? So does this go like this? Okay, expected type this, found that, so I need to put a little question mark in front of this. Value of type blah 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 ignored, so set callback. set key callback, we can ignore the response because it's just the old function pointer, which I don't care about. Ring buffer, this should be const action FIFO is this. And then here we can say action FIFO dot init which will take in an allocator, which probably means that on dinit we need to free this thing actually. So we have to do like self actions dinit this. What else? What else? What else? Read is the wrong thing now. We want to read item. And here it's probably write item. Okay, pointer cast increases pointer alignment, so we have to align cast this as well. And error is ignored on write item, so 226. We're going to say catch here, since there's no way to report errors back, and we'll just log it. Failed to write action to FIFO, which I don't think should ever happen. Failed to handle input action, we'll call it. So I think that the implementation details being in the log don't really make sense. Division by 0 has undefined behavior on size of t. Why is my size of t 0? Oh, because it's only got one element. So here I probably have to specifically ask to be backed by U8s. Probably. No, I don't want to download. I want to learn. And then I want to go to the standard library docs, and I want to look for... No, I don't want standard library docs. I want language reference. I want to look for enum. Yeah, here we go. Two-step got me as well, but I was already on my way. Okay. So let's see if this actually does what I expect it to. We've got to get rid of that head.n1 or -n10. So this is we're getting the notification on key down and key up. So we need to specify that we only care about action. It's probably action is up or something. Release. So this is equal to C glfw release. Boom. Close. I guess, does it make more sense for it to be on key down? Probably does. Probably does. Because probably, I'm imagining usage of this is I'm going to be looking for a specific point in time in the video, and I'm going to be slamming the pause button at that specific point in time. So it being only on key down makes sense. And there's no, it's not coming up on repeat, which is good. And so now all we have to do is we set the pause variable. How do we want to... Let's maybe say call something pause time. And this is going to be a instant. And the idea here is, instead of making it a bool, I say, when did we pause? So that we can adjust the start time when we unpause, so that when we try to pull new frames, we're not pulling initially to, like, we're not pulling relative to when we initially started the video, but when we last unpaused, if that makes sense. So here we'll just say that if pause time is null, I don't know how to check if it's null actually in this language. It's crazy that I haven't come across this yet. Optional. Equals null. Oh, of course. Derp derp, thank you. So if it's null, well, I guess it probably makes sense to do the other way actually. If pause time pause time will now equal to null because we are now unpaused, and start time plus equals now minus t. Except we don't have plus equals, it's going to be start time since, oh gross, stood time instant. Is there no way to like add and subtract these guys? We can get elapsed time. But we can't like add and subtract other instants, which is a little annoying because it just means that this is hard to work with now. So can we just convert the time into like milliseconds since epoch or something? Like, can I just convert this into like some number? Is there like an instant reference? Okay, because if it's a U64, that's straightforward. But if it's a POSIX time spec, then we actually have to like handle it differently. Oh, that's disappointing. Probably need a duration like Go. I don't know if the duration helps us here. Because we need to like reference, we're like playing the video and we're saying like, hey, how long has it been since this point in time? And then that point of time changes when we pause and unpause. But I guess what we could do is we could write down how far into the video we were when we paused. You're saying timer worked well for you? I don't think this provides what I want either. Because this is saying like, hey, we're starting at the beginning, and then we can like check, we can... Here's what we'll do. We're going to store the pause time as a duration. How far into the video we were at the time we paused. So this is going to be now my since start time. Okay. Then when we unpause, what do we get out of this? A U64, and this is gonna like be accumulated to some adjustment. Yes. And so when we unpause, we will increase that adjustment. So it's like now since pause time. Oh, so this is actually a time. I lied. This isn't a U64. This is an instant. Yes. And then now since t. And then this is just now. Does that make sense? So here, when we pause, we go, hey, we paused at this time. And then we say, hey, add the amount of time that's passed since the pause to the time adjustment. And then here, we say, now since start time minus time adjustment. And I think that makes sense. And we also don't want to do this if we're paused. So we'll say, while pause time is equal to null and all of this stuff. Oh, baby, look at that. Pause. Unpause. Boom, 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 boom. Okay. I think that's working pretty good. Okay. Okay. Yeah, it feels good. I was really hoping to get farther today. I was really hoping to get to like seeking support as well, but What even tripped us up for so long? I guess it was like this aspect ratio stuff just took way longer than I expected. That's probably what it was. Okay, but good progress for today. Good progress. I was hoping for more, but it's not bad. So what do? We split out our GUI stuff into like its own module. It's getting a little bit more library-like, which will be useful later down the line. We fixed the like green bar that was on the edge of the video, so that's gone now, and we fixed so like the aspect ratio is preserved now depending on window size, which is pretty sick. And then we just added this like really rudimentary pause play. Looking good. Okay. Looking good, I blame OpenGL. No, I think the problem was more that I'm just too stupid to work in like coordinate systems. Like just remapping coordinate systems just hurts my head so fucking much, man, every time. Okay, so if you like what you saw, we stream most days at around 2 o'clock Pacific time. It's just after 4 o'clock Pacific time now, so if you're watching live, then it would be 2 hours ago to now. Wait, I still see a green bar. It's really small, though. It's really small. You should, like... hold on. We'll go back. Git add-u, git status, git commit-m smiley face, git checkout, origin, master. Before it was like this. Like this, we had this massive green bar. Now there's a tiny green bar, and we're willing to live with the tiny one. Okay, sorry. So, yeah, if you like what you saw, we stream most days around 2 o'clock Pacific time for around 2 hours. We're working on this like video editor right now, but there's a lot of other stuff that's been worked on in the past. So if you want to check out previous work, you're going to see stuff on YouTube and GitHub. Links are in the Twitch description, and they're organized in playlists on YouTube. So you'll see stuff like Rust operating system, QR code scanner, virtual file system, neural network, ASCII generator thing. What else is in there? Diff tool. There's lots of stuff. Go check it out if you care. But otherwise, I think that's all I got to plug. If you're watching on YouTube, there should be a Twitch link in the YouTube description if you want to swing by and say hi. Otherwise, we'll say bye to YouTube now, and on Twitch, let's figure out who to raid. Thanks for watching, guys. Catch you later.